So we're going to step back a little bit and review some stuff today before we move on. We want to review our conversions first of all. Things like six yards going into feet. How do I make that conversion? I put 6 yards over 1. My conversion factor then, where's yards going to go in my conversion factor? On bottom, so they cancel out. And of course, it's going into feet, and the relationship is 3 feet and 1 yard. So here the yards cross out. We're going to multiply 6 times 3 feet is 18 feet. On bottom, it's all 1, so that's just 1. So 6 yards is 18 feet. And yes, I do realize many of you probably could have done that calculation in your head because you know there's 3 feet in a yard. Let's look at something like 5 yards going into inches. Gotta love that reaction. So 5 yards, put it over 1. And it's going to take a couple of conversion factors here. Put yards on bottom so it cancels out. We could go into feet. 1 yard is 3 feet again. So then on bottom now, what are we going to put in this conversion factor? Feet and then inches. And how many inches? 12. Good. So now on top, it's 5 times 3 is 15 times 12 is 180 inches. On bottom, it's still 1 times 1 times 1 is 1, so that's 180 inches. As long as the bottom comes up to 1, we don't have to worry about it. If it's anything other than 1, of course, we do have to divide that out. We had units of area, like 3,456 square inches being converted into square feet. So I'll put my, what's that? 144, perfect. Square inches on bottom, there's 144 square inches in 1 square foot. So the square inches cancel out. So now it's 3,456 times 1 square foot is 3,456 square feet. On bottom, 1 times 144 is 144. And here's one where we do have to divide this out. 3,456 divided by 144 is 24? Yes, perfect. Or we might have, let's see here. 684 square feet going into square yards. So again, we'll start with 684 square feet over 1. In my conversion factor, what goes where? Square feet on bottom, square yards on top. The relationship? Three by 3 or 9. There we go. So then on top, 684 times 1 yard is 684 yards squared. On bottom, 1 times 9 is 9. And we divide that out to get, what is that, 76? Yeah. Perfect. Or we might have 20 acres going into square feet. Perfect. 1 acre, 43,560 square feet. Does anybody remember the one number to remember if you forget that? One chain is how many feet? Do you guys remember that one? 66 feet. So the way to remember, if you forget acres, if you remember that one chain is 66 feet, 66 squared, or 66 times 66, is 4,356 square feet. And an acre is 10 square chains. So you square the 66 and then times 10 gives you that conversion. That's probably not any easier to remember, but it's one of the ways I remember it. So anyway, on top, we've got the 20 times 43,560. What is that? 871,200 square feet over 1. Does that look right? There we go. That's a lot of square feet. When we dealt with our metric system, remember it's all moving decimal points. We had meters, decimeters, centimeters, and millimeters. If we were converting length measurements like 0.49 meters going into centimeters, all we did was looked at the chart. From meters to centimeters is 2 spots to the right. So my decimal point has to move 2 spots to the right, 49 centimeters. The reason that worked was every spot on the chart was multiplying or dividing by 10. So multiplying and dividing by 10 just moves the decimal point 1 spot. However, if this were 0.49 meters squared, going to centimeters squared, now every spot on the chart is multiplying or dividing by 10 squared. And 10 squared is 100. 10 times 10. And when you multiply or divide by 100, the decimal point moves 2 spots. So now every spot on the chart is 2 decimal places. So from meters to centimeters is still 2 spots on the chart. That's how many decimal places? 4. So we go 1, 2, we had zeros, 3, 4. That's 4,900 square centimeters. So if we have 910 millimeters squared going to centimeters squared. From millimeters to centimeters on the chart, that's 1 spot to the left. So my decimal has to move 2. There you go. So 1, 2, 9.1. Yeah. 1 spot on the chart, so only 2 decimal places. If I have 270,000 millimeters squared going to meters squared. From millimeters to meters is 3 spots on the chart, so 6 decimal places. You got it. 1, 2, 3, 4, 5, 6. 0.27 square meters. What do you think? 270,000 millimeters square sounds like a lot, right? Well, this desk right here is probably right around 1 meter squared. So it'll be a quarter of this desk. Not a lot, no. There's one of the things, we've talked about why haven't we switched to the metric system. In reality, the metric system will be way easier once we switch over. It's going to require a lot of adjustments. Like construction, you're not going to have 16-inch spacings anymore. You're going to have probably 30 centimeter spacings is what it's going to come out to be. Actually, not 30 centimeters, what would it be? Probably 40 centimeter spacings is what it would come out to be. Not so bad. We'll adjust to it. But one of the reasons that the adjustment has been so difficult for the United States is the scale. 270,000 millimeters sounds like a lot of, or millimeters squared sounds like a lot of area, but it's not. It's, like I said, it's a fourth of this desk. Getting used to the size of the numbers has been a huge adjustment for people as we try to force the adjustment. In the 1980s and early 1990s, we really tried to force it. And there's a lot of backlash, and they backed off on it. So it'll happen someday. Then we also did operations with measurements. Things like 7 feet 9 inches plus 2 feet 10 inches. And so we start, as always, we start on the right, work our way back to the left. What's 9 inches plus 10 inches? 19 inches. And of course, that's more than a foot. It's 1 foot and how many inches? 7. If you need to, you can subtract the 12 to get 7 inches left. Keep the 7 inches and carry the 1 foot. 1, 7, and 2 makes 10. You got it. 10 feet, 7 inches. we might have three rods, 4 yards, plus 4 rods and 3 yards. We'll get there. So 4 plus 3 is 7 yards. That is bigger than a rod. Does anybody remember how many yards in a rod? 5.5, 5.5. So we subtract 5.5, we're left with 1.5, 1.5 yards. Carry the 1 rod, and we have 8 rods. Good. We might have 6 feet 2 inches, subtract 2 feet 9 inches. Well, here 2 inches minus 9 can't be done, so we're going to take from the 6. That'll be 5 feet. This is going to become 14. We have to add 12 inches to it. Now, 14 minus 9, 5 inches. 5 feet times 2 or minus 2 feet, 3 feet. We might have 7 yards, 1 feet, 6 inches, minus 2 yards, 2 feet, 11 inches. As we do that subtraction, of course, 6 minus 11 can't be done, so we borrow. That's 0 feet. What's this become? 18 inches. Good. 18 minus 11? 7 inches. Back up top, 0 minus 2 can't be done, so we borrow again. 7 yards becomes 6 yards. This becomes, careful, 3. 1 yard is 3 feet. You're thinking rods. Yeah. 3 feet minus 2 feet is 1 foot. 6 yards minus 2 yards, 4 yards. Good. So let's have fun with one here. Let's take 5 feet, 11 3/4 inches. We need pieces 5 feet, 11 3/4 inches long. We need 7 of them. To find the total length that we need, well, we're going to start out with 11 3/4 times 7. Well, that's not an easy one to do, but remember, you have the right idea. 11 3/4, we're going to write as 11.75. 11.75 times 7 gives us 82.25, or 82 1/4. How many feet can we get out of 82? Well, if I need to, I can just do this. 82 divided by 12 is 6.8. So there's 6 feet. How do I figure out how many inches are left over? I can subtract the 6 and then do what to turn it back into inches? Times 12. 10.25 inches are left. So that's 10.25 inches. Carry that 6 feet. Now what? 7 times 5 feet is 35 feet. And then plus the 6 makes 41 feet. There we go. Four feet 9 inches divided by 3. Well, it's probably more used to seeing that written something like this. 3 goes into 4 feet how many times? Once. Oops, sorry, make that 1 foot. 1 foot times 3 is 3 feet. We subtract to get 1 foot. Before we can bring down the 9, we turn the 1 foot into 12 inches. Now we bring down the 9. 9 and 12 make 21 inches. 21 divided by 3? 7 inches. This next one I'm going to give you, it's going to be on the test. On the quiz, I should say, not test. Because we haven't covered gallons yet. 2 quarts, or 6 gallons and 2 quarts times 5. Well, 5 times 2 is 10 quarts. Does anybody remember how many quarts are in a gallon? 4. Let's 2 gallons with how many quarts left? 2 quarts left. Carry the 2. 5 times 6. 30 gallons plus 2. 32. So 32 gallons, 2 quarts. That problem will be on the quiz, by the way. Oh, no. You're going to get a quiz in about 2 seconds. Anybody have any questions on these? And I want to make sure we spend enough time on those, so hence the huge packet. It's me carrying out an old grudge against trees, apparently. So anyway, we've talked about areas a little bit already and how to calculate areas. We found some basics. We could find a simple area of something. Well, let's just do the triangle. Of something like that. Let's say this is 8 feet, and this down here is 19 feet. It's a triangle, so how would we find its area? 19 times 8 divided by 2. And again, the divided by 2 is because it's half of that related rectangle. The related rectangle would be 19 by 8 divided by 2 to make it into a triangle, which makes that, 76 square feet? Is that area then? We even found triangles that weren't right triangles as long as we knew the dimension of a base. The base is simply one side of the triangle. It doesn't matter which side. We've typically used the bottom as the base, so I'll do that again here. We'll say the bottom here is 28 inches. But then the second piece we need has to be perpendicular to the base. What does the word perpendicular mean again? Right at a right angle, yeah. So perpendicular would be like that. And it has to, of course, give us the width of that related rectangle. And so the width of that related rectangle, to get that distance, we go to the furthest point on the triangle, which is the only corner or only vertex of the triangle that's not part of the base. These 2 corners are part of the base, so that altitude has to go to that other corner. And that is called an altitude. And it is simply the distance from the base to that farthest corner, farthest point in the triangle. If we give you that is 11 inches, the area of the triangle is found by doing what? There we go. Base times height, 28 times 11, and then divided by 2 because it's half of that related rectangle. Is that 154 square inches, I believe? What if we have a triangle that does not have any right angles in it, and does not have an altitude? All we are given is the length of all 3 sides. Well, we can still find the area of it. It's not nearly as pleasant, but it uses something called, depending on the textbook you're looking through, it's either Heron's formula, or some textbooks just refer to it as Hero's formula. It was a Greek mathematician named Heron that actually created this formula, or discovered this formula. For some reason, some textbooks shorten his name to Hero. Doesn't matter to me. What's that? It does, yeah. Anyway, Hero's formula is actually more of a process than a simple formula. The first step is to find the perimeter. How do we find the perimeter of a triangle? Add them all up. So 19 inches plus 18 inches plus 11 inches makes 48 inches, I believe. Perfect. Now the next thing, the hero actually defines something called the semi-perimeter. The semi-perimeter, abbreviated just S in this case, is the perimeter divided by 2. So 48 inches divided by 2 is going to be 24 inches. And it's that semi-perimeter that the formula for the area is based off of. The area of that triangle is the square root of, and yes, I do need that much space, the semi-perimeter times the semi-perimeter minus one of the sides times the semi-perimeter minus another one of the sides times the semi-perimeter minus the third side. Usually I do the sides either shortest to longest or longest to shortest. Really doesn't matter. No, it's just my way of keeping track. So our semi-perimeter is 24 times 24 minus 19 times 24 minus 18 times 24 minus 11. These are pretty easy subtractions, so to make it easier to put in the calculator, I'm just going to subtract them. 24 minus 19 is 5. 24 minus 18, 6. And 24 minus 11, 13. So let's just punch those in. And this is so the square root of 24 times 5 times 6 times 13 is 96.7, we'll call it 96.75. Those units were in inches, so this is inches squared. Now, when you say mental math, all I can think of is the math you'd do in the loony bin. Don't know why it always occurs, it always gives me that image. But. So we were able to find the area of this without knowing an altitude or without having any sort of right angle for it. Not a real pleasant formula, though, is it? So I'm going to have you guys try one on your own. Somebody give me a number between 7 and 20. 18. So we'll start off with 18 feet. Find the area of that triangle for me using Hero's formula. You must have fixed this, so it's latching.
No, you gotta pull the inbuilt money.
Yeah, it's kind of messed
latch. Yeah, like open it, and then like open up.
Okay.
And then basically, and then close it.
Can you close it?
And then pull the latch like kind of towards the frame.
Oh, like this?
Give me a quick.
Yeah, then it'll click and wow.
That's sad. At least the box. As clear as I said, I saw him wonder, I was going to mention it to him. It still wasn't latching, just so somebody doesn't come in here and
Take all the locks.
well, considering what is there, like, there's like close to 30 batteries sitting in here.
Yeah.
And those are like $90 a piece.
More money than like handle that.
There's about $3,000 just in batteries sitting here.
Yeah, I see if I need to just.
Well, some of those don't even have to be.
And that's what we board just pops open. Sure. Formula. There like that.
Oh. Oh. Do you own? I do own. I think all the ones that are wrong. So on this one.
No, I'm why they keep calling me in class. They know I am a high schooler, so they know that.
Yep. Let's see what we get for this, and then we'll take a break quick. So we're going to start with a perimeter. 80 plus 82. Perfect. 180 feet. Perfect. 90 feet for the semi-perimeter. So that'll be the square root of
90 minus 18 times 90 is 80 times
Yep.
times 90 minus 82 yeah.
So then the final thing is 90 times 72 times 10 times 8.
Perfect.
And I got the answer out.
And then you square with that, and it's 7,200.
Hey, you got it wrong. How did you do it?
Well, that works out. Oh, I see what I did. It is 720. Of course, those are in feet, so this will be square feet. Now, this came out to be a whole number. That does not happen very often, which means that this is actually a right triangle. So we're going to take a break, and we're going to come back, and we're going to look at how you would know that that was a right triangle. As promised, we talk about how would we know if that was a right triangle. Well, let's start out by going back to something that we do know is a right triangle. 5 feet by 12 feet by 13 feet on the sides. In a right triangle, in any triangle, there's 3 sides, but in a right triangle, 2 of those 3 sides make the right angle. The way you can think about this is that right angle looks like an L. Those 2 sides that form the right angle are called legs. The other side is called the hypotenuse. Now, if you don't know whether a triangle is a right triangle or not, you can always tell which side would be the hypotenuse because the hypotenuse has to be the longest, opposite the 90-degree angle and the longest side. So yes, it's the only side that does not touch the 90-degree angle, so it's opposite or across from it, and it's the longest. The rule, if we label the legs sides A and B, and of course the hypotenuse side C, you've all seen this one before. A squared plus B squared equals C squared. Called the Pythagorean theorem, or Pythagorean rule, depending on... We're just going to call it A squared plus B squared equals C squared. So here, we're going to plug in for A, what number? 5. So 5 squared plus what goes in for B? 12 squared, and for C? 13 squared. So 5 squared is 5. 5 times 5 is 25. 12 squared? 144. And 13 squared? 169. And 25 plus 144 is 169. So it does work out. That is a right triangle. So back up to this one, where we weren't sure, what we'd have to decide is what side, if this were a right triangle, what side would be the hypotenuse? 82. So that's side C. The other 2 sides are A and B. So A squared would be 18 squared, plus B squared would be 80 squared plus C, or sorry, not plus, equals C squared would be 82 squared. Well, 18 squared is 324. 80 squared is 6,400. 82 squared is 6,724. If I add those two up, I get 6,724. So yes, it is the same value on both sides. That is what's that? So it must be. And of course, the right angle has to be there, between the two shorter sides. So I could have just found that area by doing 18 times 80 divided by 2, which is going to give us 720 square feet. So being able to check before we jump into that hero's formula would save us a lot of work on these. It would. Yes. Somebody give me another number between 7 and 30. 8. I heard 8 first. We'll do 21 next. So here, let's check to see if this is a right triangle. I kind of drew it like a right triangle, but let's check to see. So what two sides would have to be the legs? 8 and 15. So 17 would have to be the hypotenuse. Now, I'm not going to put an equal sign here because I don't know if they're equal yet, but it would be 8 squared plus 15 squared, and the other side would be 17 squared. 8 squared is 64. 15 squared, 225. If I add those together, I get 289. What's 17 squared? 289. So those are equal. So this is a right triangle with a right angle where? Between the 8 and the 15. So the area is 15 times 8 divided by 2, otherwise known as 60 square inches. So Peyton gave us the number 21. Let's try that and see what happens. Let's go 21 feet on one side of our triangle. Oh, let's see here. This one's a little tougher to do. Let's see what happens here. If I were going to test this one, what would I do? Tell me where to start. Okay. Of course, C would go there. So then what? 221 squared over here. Okay. So 21 squared is 441. 220 squared. 4,800. Yeah, 48,400. If I add those together, I get 48,841, correct? Yeah. Yeah, if you tip it sideways, it gets you the scientific calculator. A lot of people don't realize, there's a scientific calculator if you just tip it sideways. And then even then, some of them you can swipe to the side and get even more functions. Yours doesn't? 221 squared is 48,841. So those are the same. So that is a right triangle. Someday, if we have extra time, I'll show you guys how I can actually create a right triangle when you give me a random number like that. But maybe not today. Where this is really useful is if we have a foundation. Let's say that this is 36 feet here and 48 feet here. When we go to set the foundation, let's just say we're doing a garage, so we don't have to do a basement, but you would do your concrete slab yourself for a garage if you're doing construction work. To square this up, it'd be nice to have a corner-to-corner measurement across here so you know if you're getting this square. Well, how far should that be across there if this is a right angle? Well, that is the hypotenuse, correct? And the 36 and the 48 would be the legs. So it would be a squared is 36 squared plus b is going to be 48 squared equals c squared. Now here's what I'm going to do is I'm just going to make that c, and I'm going to put a square root over here because to find c I'm going to have to square root that. So, oops, turn on. The square root of 36 squared plus 48 squared gives us 60 feet. So that has to be 60 feet across there. So when you set those two sides, you can measure across to make sure it's 60 feet before you set the other two sides. Easier to change it before you set two more sides. The other way, of course, is once you're done, you always measure, let's get back there, both corners, and they better measure the same both directions. Let's say you do that. Get off topic just a little bit, Jerry. Let's say you measure across. I won't give you dimensions for the sides, but let's say you're measuring diagonal, and this one here is 28 feet, 6 1/4 inches. And this one going this direction is 28 feet, 4 3/4 inches. If I'm going to move this corner, these two corners, to make this better, which direction do they have to go? Up or down? Down. If I move them down, that makes the red one shorter and the green one longer, and that's what we need. You'd be amazed at how many times I've been on a job site and watched people do that the wrong way. Just like reading the transit that we did there a few weeks ago. People read it wrong. They want to go down 2 inches. They subtract 2 inches instead of adding 2 inches. Yeah, we're going to have way more fun with it now. So for this trapezoid, I want to find both the area and the perimeter.
Well, to find the base of that right triangle on the right there, you got to subtract 6 and subtract 22.
Okay, so you can, that's a good point. We can find this one here from 43. We subtract 6, which would be 37. That 37 would be from here over, right? Then we subtract 22, gives us how much? 15. So the base of that triangle is 15. Good, that's a start. What more can we find? Well, I need to know this length here for perimeter, don't I? Don't have any information that's going to help us with that right now. Okay. Oh, perfect. We're trying to find one of the short sides. You're talking about on the left side over here? So we're trying to find that side that's one of the legs instead of the hypotenuse. So for that, we're going to work backwards. If a squared plus b squared equals c squared, if we work backwards, c squared minus b squared equals a squared. So what we're going to do is this. What's c there? What's the hypotenuse of that triangle? 10. So 10 squared minus 6 squared, and then we'll square root that to find a. Ends up giving us that a equals? So the square root of 10 squared minus 6 squared should give us 8. Then you square root it. Yep. So there we go. We get 8 there. Which means that this dimension here is 8 feet. Because those have to, these two sides are parallel, which means they're always the same distance apart. So they're both always 8 feet apart. Now that we have that, we can find this distance here by, you got it, 8 squared plus 15 squared, and square root that to get C, which gives us 17 feet. Yeah. How did I know that? Yeah. I didn't use the calculator. You're supposed to not tell them that and mystify them. So anyway, the perimeter then is going to be found by adding what? Yeah. So it'll be 22 plus 10 plus, well, 43 is already all the way across. So 43 plus 17. What was that, 92 feet? $92? Perfect. Let's look at then the area. Remember, we had that area of a trapezoid. We averaged the two bases together and multiplied by the height. So here, what is the big base? 43. What's the little base? 22. We're averaging them together, so we're going to add them together and divide by 2, and then what's the height? The 8. So 43 plus 22 is 65. Divided by 2 is 32.5. Times 8 is 260. Those were in feet, so that is square feet. So we're going to find the perimeter and area again. Let's do... Somebody give me a number between 8 and 30 again. 17. Good number. So on a figure like this, that's a parallelogram. Assume both pairs of opposite sides are parallel. To find the perimeter, it's pretty easy. What do I do to find perimeter here? Add them all up. Perfect. 190 inches plus what? Plus 190. Good. We don't use the 17 because 17 is part of this 190, right? So if we add those all up, what do we get? What, 680? 670. Thank you. There's our perimeter of 670. For area, we need to know a height. How are we going to find that height? Yes, the square root of 145 squared minus 17 squared. Giving us 144. So how do we find the area then? 190 times 144. Do we have to divide by 2? No, because that is the rectangle. That is the full rectangle. Remember, this part just gets cut off and put over here. So 190 times 144, it's that point in the day where I'm using the calculator for that. 27,360. Oops. That's supposed to simulate a pencil rather than a pen. It's just really annoying is what it really amounts to. Square inches. Pretend that looks like a half circle. Kind of looks like a head.
Oh, that was actually good. That's so mean. Oh.
So here we go. Let's find perimeter and area of this. As we look at these, what would those two green links be that I just put in here? Yeah. So 370 minus 210 is 160, and half goes to each side. So each of those is 80 feet. Then we need to know the slant length here. We're going to find that slant because, well, this is 80 and this is 200. And we'll find that by doing, you got it, square root of 200 plus 80 or minus 80? Plus 80 squared. Those are the two legs. We're looking for the hypotenuse. So that gives us 215.41 feet on each side. Now we need the distance around our half circle. How are we going to find that? Well, the circumference of the whole circle would be pi times diameter of 370. Then it's a half circle, so we divide by 2. So pi times 370 divided by 2, so 3.14 we'll use times 370 divided by 2, 580.9 feet. Well, to that, we're going to add another 215.41 over here, and another 210 down here. So we add those up. We got 2, 8, 17, 1, 2, 1,221.72 feet for perimeter. Does that look correct?
Yeah.
Works for you? All right. For area. So for area, we have two distinct shapes, We have the trapezoid and we have the half circle. Let's do the trapezoid first. What are the two bases of the trapezoid? So 210 plus 370 divided by 2. And then times height of 200, right? So now here, what I would do is rather than adding these together and dividing it by 2, I'd divide the 200 by 2 to get 100 just because it makes the calculation easier. We talked about those patterns to make calculations easy. That's one of them. So what do we get? 580 times 100 is 58,000 square feet. For the trapezoid. How about for the half circle up there? Well, for area of a circle, we don't need the diameter, we need the radius. How do we find the radius? Yep. So what is the radius here? Yeah. 185. Good. So the area of that circle will be pi times 185 squared, and of course, divided by 2 because only half is circle. Giving us 11,343.25. Square feet. Adding those together gives us a total area, 69,343.25 square feet. If this were a lot for building a house on, how would we turn that into acres? 43,560 square feet in an acre. So I put an 8 there for some reason. That should have been a 9. So 69,343.25 divided by 43,560. We get 1.59 acres. What do you think? Good stuff? All good? Okay. So in your packet, page 144, 147, there's gray boxes, and page 156 through 157. Yeah, 144 through 147, there's gray boxes with problems in them. And then 156 through 157, there's another set of gray boxes. What pages? That works. So we'll use this packet pretty much exclusively for the next week or two. Then we'll be back and forth between the book and this packet. Wherever. If you need extra space, use whatever. There's a lot of different things in this packet, yes. Yeah, 156 through 157 as well.